Okay, let me describe the setup we're going to use tonight. We're going to attempt to put this transmitter on the air for the first time. This T19 ARC-5 is the one we've been working on. It has not been on the air for probably 40 years. We have a receiver. It's a BC348Q. This receiver is running on its dynamotor. You can hear the dynamotor running. We have a watt meter, and we have a frequency counter set up. Okay, we're putting out almost 30 watts. Still warming up a little bit. It'll be there in a few minutes for the net. The old military radio net gets on at 9 o'clock every Sunday night on a frequency of 3750 kilohertz, 3750 kilohertz. Let's listen to the note a little more critically. Tune the transmitter a little bit. There's a little bit of a warble when it first comes up. Hear that? It's not a perfect note, but it's not bad. Now this is of course being relay keyed, so if I turn the receiver down, that's what you'd hear, that relay noise. With the cover on, it's not going to make much difference. Now, it's not good to run the transmitter with the cover off because you could accidentally touch the top of the tubes and that would give you a bad shock. And also it would cause some interference to come out of the transmitter, and that top acts as a shield. So the operating conditions on the transmitter are approximately 500 volts for the high voltage, 220 volts regulated on the oscillator and the screen grid of the 1625s, and 24 volts DC for the filaments and the relay. Now that's the fault of the BC348. It's not the transmitter's fault. The BC348 overloads quite easily. It does not have great regulation with its dynamotor. So some of this is overload of the receiver. The transmitter probably sounds a little bit better than what we're hearing out of this receiver. As this transmitter is made to transmit into a short wire, not a 50 ohm cable, I have done an addition that I did not discuss before. I have added a 100 picofarad capacitor in series with the antenna terminal to the coax. That allows the roller inductor to work with that capacitor and affect a pretty good 50 ohm match. And look, I'm using about half of the coil. If you watch the watt meter, if I bring the coupling down, the output goes down. Notice how the tone changes. Tells you that there is some effect of the power amplifier pulling the oscillator slightly. So it's not a perfect transmitter. A MOPA does not have good isolation between the oscillator and the amplifier. So depending on how you load it, you will get some variations. Well, this is the roller inductor. Getting a little clicking. Of course, with the RF on, and using the roller inductor, you need to have very clean contacts or there could be some arc over. But it's not bad. It's a pretty nice note considering how old this transmitter is. So I feel very confident we're going to be able to use it to check into the net tonight. So let's see if we can hear anything. Sounds like somebody is tuning up already on frequency. This receiver, the BC348, was the main receiver in the B-17 bomber and the B-24 Liberators. It does have a crystal filter feature. Pretty sharp with that crystal filter in. But the filter is quite lossy. So it's just before net time, and maybe we will go into a dummy load and see what the stability of the set is like. It's been warmed up now for about 15 minutes. So let's see what we can do here. Okay, 3570, 015, 012. Pretty stable, isn't it? That's what they mean when they say legendary stability. Unbelievable. It's just staying right on frequency. Just about net time, so we'll come off the dummy load and get back on the antenna. He's calling the net. How do you like that? First call, no problem. He's running a GRC-19. Up to the Vermont station. You hear the back wave on that transmitter? There's some back wave. That was what we were trying to describe before. Rig. It's the PRC-47, which is a Vietnam-era transceiver. It sounds like the oscillator is only turned on when he's transmitting. When he lets up, sometimes the back wave goes away. It's very interesting. He's going to turn it over to me. As you remember, we fooled around with the capacitor in the VFO compartment. I just pulled it out so we can look a little closer. And I put the capacitor approximately in the same position. We were just operating on 3570, and that's where the dial is set. Let's look at this. This would be 3550, 3560, 3570. So it's right on the line. And when we go to transmit, and we look over here, we see that we're about 536 hertz high. Of course, all I have to do is just touch this dial. You can hardly see that I moved it. Now we transmit again. And there we are, about 5 hertz low. So that's about as good as you can do on the dial. You're not going to be able to do any better than that. What we haven't done is checked our calibration point. And if we look back here, we see the crystal. It's 3265. So let's go down to 3265. So I've got Got to move the dial quite a bit. 3265. Now we're into a dummy load. Of course, this is outside the 80 meter band. So 3250, 3260, 3265, 3265, someplace in there. So if we transmit, let's see if we can get that eye to open up. Oh, it's just about perfectly open already. So there it is. See the eye? See how that opens up around the crystal? And that's your calibration point. That's how that works. The eye is open, 3265, but when we look over on the meter, it says 3264446. So we're 500 hertz low, 500 or 600 hertz low, and that's due to the aging of the crystal. The other interesting thing to note is I have not touched a tube in this radio. I have not changed the tube. I have not selected a VFO tube. Everything works. You know, you should have seen this radio before I worked on it and gave it a bath. It was bad. You didn't see the before picture. It was pretty bad. As a matter of fact, it was so bad that I picked this transmitter up and another like it for a grand total of $10. That's right, $5 each, including the tubes. Two disc capacitors. They're both 1500 puffs each, so in parallel that's 3000 puff. That capacitor was missing completely in the radio. On the bottom of the set, the 200 puff capacitor that goes from the cathode of the 1625s to ground was not even connected. It was flying in midair, and a couple of the relay wires were cut. So this was not a pristine transmitter. There were several things I had to go through to make sure that electrically it was working. But all in all, it really came back nicely, and this is going to make a nice transmitter. Here's some DX coming in, an RU3. Let's see if we can get him. Try to zero beat him as best we can. Close enough. We'll give it a shot. Let's try him. He hears us. I hope that you've enjoyed this series on the ARC-5 transmitters. The SCR-274N transmitters, the ATA Navy sets. Too many times we find these transmitters in the ham shack, but buried somewhere up in a closet or under the bench. We need to get these things out, get them on the air. The 40 meter version would be a wonderful thing to put on and operate in some of the Antique Wireless Association events, like the Link Kundal contest that's coming up in January. So let's get these things on the air. And I want to let you know that this video was made over Christmas break 2011.